A warm welcome to the today's session. So today we are going to have a tutorials on the load curves and load duration curve. First of all, what do you mean by load curve? So load curve is nothing but the correlation or a graphical representation between your power along with the time. So load power along with the time, we are going to have a load curve is going to formulated. The load duration curve is nothing but the duration in which the load prevails. So the load curve and load duration curve is much and much important for the load forecasting. So in extension to the load forecasting, the load forecasting has a predominant role in this load curve calculation or load curve sketching. So today we are going to have a tutorials on the load curve. So first of all, consider a problem. So in this problem, we are going to have a generating station. In this generating station, we are having a following data. The data which depicts 0 to 6 hours of 4500 kilowatt, 6 to 8 hours which compiles of 3500 kilowatt, whereas 8 to 12 7500 kilowatt, followed to 12 to 14 hours 2000 kilowatt, 14 to 18 8000 kilowatt, 18 to 20 2500 kilowatt, 20 to 24 5000 kilowatt. So the problem is here begin this way. So sketch the load duration curve and determine the load factor and plant capacity factor if the capacity of the plant is 12 megawatt. So in this we are going to have a discussion for finding the load duration curve in along with the load factor along with the plant capacity factor. So we are going to begin this way. So we are having a set of data. So we are going to have a sketch over the load duration curve now. So the load duration curve is going to begin this way. So I am going to take a curve which depicts time in x axis, whereas my load in the y axis. So here which a clear notation which provides over the correlation between your load along with the time. So in this we are going to have a load database now. So 0 to 6 hours, for 0 to 6 hour which may comprise of some 4500 kilowatt, and that too provides for the 6. So I am going to sketch this way. So 4500 to for all its 6 hours is going to begin this way, whereas my 6 to 8 hours is going to begin by 3000. This is what about my 4500, and this is my 3500 kilowatt which is going to begin for 2 hours. So 3500 kilowatt, and thereby which is going to enhanced over the range of 7500 for a period. So 7500. So that too provides for the prolonged days of 12. So my sketching is going to begin this way. So for 12 it is going to enhance over the period. So 12 hours is going to enhance, and thereby 12 to 14 it is in the range of 2000. So I am going to have it now. 12 to 14 it is 2000, whereas it is in the range of my 7500. So my sketching is going to begin this way, and thereby the sketching is going to increase then and there. So it is 2000 megawatt, and thereby it is going to enhance again by 8000 megawatt, and thereby it continues over there. So 8000 megawatt, and there it going to begin. So 14, 16, 18, 20, 22 is going to begin this way. This is the load curve. So I am going to have a discussion on the low duration curve, and that too much and much important for our current consideration, that is required for the current view now. So I am going to scribble this now. So for a consideration, I am going to rub it off everything, and I am going to have a clean sketch now. So here I am going to tabulate the entire things in the descending way, and thereby the load is getting depicted on the first column, whereas my time is going to begin in the next one, duration. Load versus duration. So for the 8000, it's going to begin in the descending way. For 8000, the range is being here. So 8000 kilowatt. So 8000 kilowatt is for the period of 14 to 18, and thereby 4 hours is going to prevails. And next descending range, which is in the range of 7500. So I am going to begin 7500 plus. So here the plus which notates above category. So over and above 7500 plus, that's supposed to be on the 8000. R is going to enhance in the range. So it's going to be in the range of 8. So how do you will get that 8 means? So 7500, here we are going to have a 4, and here we are having a 4. So 4 plus 4, we are getting 8. So next 5000, I think the next option is 5000. Here 5000 plus. So 5000 means here we are having a 4 hours and followed by the 8 hours. So it's going to be a 12 hours. So going to begin this way. So 5000 is over now. So next I am having a 4500. So 4500 means 4500 plus. So here we are having a 6 hours plus 12 hours. It's going to be in an 18 hours. So next my range lies in the 3500. So 3500 which is lies for a 2 hours. So 3500 plus going to be for 2 hours, and entire notation is going to be on the 20 hours. Then 3500 plus again 2500 plus. So 2500 plus by the range of 2 hours, and net duration is 22 hours. Then final range which is on the 2000. So my 2000 which is lies in the range of for a period in the period of 2 hours and totally of 24 hours. So my net hour is getting satisfied over here. So my entire 24 hour is going to have a clear notation over now. So when I am going to have a low duration curve means this way. So that's what about my load curve. Now I am going to begin with the low duration curve. So the low duration curve, which is going to be again the simplest curvical notation which depicts the x and y axis, whereas my x axis is here. My x axis is going to begin this way. The duration is mentioned in that x axis. So it's what about my duration in hours. my duration in hours, followed by which we are going to have a load now. So load going to be in that kilowatt. So is here going to mention in the kilowatts, right? So next my tabulation is going to begin this way. So I am going to consider a duration with respect to some 4, 8 and so on. So 4, 8, 12, 16, 20 and 24, right? So this is what about the entire duration, whereas my load is going to begin by 2000, 4000, 6000, finally 8000. So the load duration which is going to have a discussion plus, so thereby it's going to depict over here. So 8000 is going to for a prolonged period of 4 hours. So I am going to mention in the 4-hour curve. The next I am going to have a discussion on the 7500 which prevails for 8 hours. So totally which comprises of 8 and this way. So 7500. So next my duration, here you are going to mark, means you can mark, so 4 hours. So it's going to be an 8 hours for the prolonged period, is going to be an 8 hours. So I am going to begin the next way. So 7500, next I am going to have a 5000 plus, right? So 5000 plus is going to provide for 12 hours. So 12 hours is mentioned here in the notation here, and followed by that 18 hours. So we are going to have a next thing. So 12 hour, then 18 hour, it's going to be a 4500 plus. So next I am going to have a 20 hours. So 20 hour is 3500. So if you want you can mark, or else you can leave, there is no need at all. So then I am going for the 22 hours. So I am going to for that 2500 in the range, right? So 2500 in the range, and thereby the 2000 plus range is getting evolved, right? So it's going to be for the 22 hours, and it's going to be an 24 hours. So this is the curve which clearly notates your load duration curve. So from this load duration curve, so we are having a yet another factor is going to determine here, and that's supposed to be plant capacity factor. Another one is load factor. So we are going to have a determination now. So I just rub it off this entire thing. So I am going to begin the load duration now. So here the entire plant capacity which is lies in the range of my plant capacity which is lies in the range of 12 megawatt. So I am going to reconsider my capacity of the power plant is these are all the 12 megawatt, I think so. So I am going to depict by 12 megawatt. So 12 into 10 to the power 6. So I am going to have a 12 kilowatt now. So this is what about the capacity. So my final determination has to be in the way of plant capacity factor, which is having a formula of plant capacity factor which is having a formula of average demand divided by my rated capacity. I am having a rated capacity now, but my average demand is not getting applied over here. So I am going to have a entire thing again. So I am going to have a yet another formula which is going to apply now. So that's for about my for average demand. So average demand is going to calculated in this way. So average load or average demand is calculated by my average demand is going to calculated in this way. That's supposed to be units generated divided by my entire time in hours. Here the now units generated is not getting obtained over here. I am going to calculate this unit generated now. So I am going to calculate this unit generated now. So unit generated is which is going to calculated in such a fashion that this table. So this table which clearly notates this 8000 plus 8000 which provides for the 4 hours, and thereby 7500 which provides for 8 hours, and my 5000 is going to begin for that 12 hours. So this the entire generation is going to have a calculation. So we are going to have this calculation now. So average load is going to calculated through by means of units generated. So I am going to calculate this unit generated now. So unit generated is can be calculated through by means of the formula. So 8000 for a period of 4 hours. So since I am going to have a discussion on that prolonged 24 hours for 4 hours, then 7500 for the period, right? So 7500 for the period of 4 hours. So by this way, you are going to have a calculation, and thereby the unit generated is going to obtained over here. The unit generated is going to obtained through by means of 125,000 kilowatt hour. By calculating this, we are going to obtain this unit generated, and thereby the average load is getting calculated. So average demand, we get that value is, so average demand is 125,000,000, and thereby we are going to have a 24-hour time period, and thus we obtain the value as 5280. So this is my average demand. So from this average demand, it is clearly notated that we can easily calculate the plant capacity factor now. So I am going for the plant capacity factor now. So plant capacity factor is nothing but average demand, that's supposed to be 5208, and divided by the rated capacity, my rated capacity in this way. So I obtain that value as 12 kilowatt, and thus I get that value as 12 into 10 to the power 3, I think so, 10 to the power 3 kilowatt, and thus I got that value as 12 into 10 to the power 3. So overall I obtained the plant capacity factor as 0.43. So thus I obtained the plant capacity factor, so PCF. So in yet another factor we are going to obtain here is load factor. So we are having a formula now, load factor. So load factor is nothing but the average load divided by maximum demand. Average load divided by maximum demand. The maximum demand for the period is lies in this way. My maximum demand is going to be in the 8000. So I am going to obtain here. So 8000 is the maximum. Right. So, my average load is 5208 and overall I obtain the load factor in the range of 6.651. So, this is the load factor value. So, from this class it is clearly inferred that we can calculate the load factor along with the plant capacity factor through by the load curve or load duration curve. So, if you had any queries means you please ping me. Thanks for watching.